Hi everybody, and welcome to the first video in the probability unit. Today we're going to take a look at vocabulary and basic ideas surrounding probability. We're going to talk about coins, dice, decks of cards, and eventually we'll look at more complex examples. What happens when we roll 2 dice, or flip 5 coins, or deal multiple cards from a deck. But for now we're going to take a look at some basic vocabulary so we have a framework to discuss these things in class. And the first word we're going to look at is the word event. An event is simply an outcome or a combination of outcomes. When we look at rolling a die, some example outcomes could be, perhaps we just want to know what's the probability of rolling a 6. That would be considered an event. Maybe rolling a 3. Or what happens if we roll an even number? Here we have a combination of outcomes. That could be a 2, a 4, or a 6. What happens if we want to roll a number greater than 2? That would also be a combination of outcomes. But each of these descriptors are what we call events. Now when we do probabilities, sometimes it's helpful to make a list of all the possible outcomes. And we have a name for that. That's called the sample space. A sample space in probability is simply a list of all the possible outcomes. So let's take a look at some simple sample spaces. When we roll a die, think about all the things that can happen when we roll a die. There are 6 different things. Just list them 1 through 6. That's called a sample space when we just list them like that. What about when we flip 2 coins? What are all the ways that 2 coins can be flipped? We flip 2 coins, we could get a heads and then another head. That's one way. Perhaps it is that the first head is heads and the second coin is tails. That'd be another way to go. What if we do it another time and we get tails with the first coin and heads with the second coin? Those count as different outcomes. And finally, perhaps we get tails, tails. So we see when we flip or toss 2 coins, there's 4 possible outcomes. That's the sample space. The last one in your note sheet there is tossing 3 coins. I'm going to leave this to you as a challenge. Take some time after this video is over, or pause it now, and try to generate the sample space for tossing 3 coins and ask yourself how many things are in that sample space. Next, now we're going to get to the big idea, which is probability. Probability, quite simply, is a number which measures the likelihood of an event. It tells us how likely or unlikely something might be. There are a number of rules which govern probability. We're going to look at 3 of those rules here. The first rule is that probability must always be a number between 0 and 1. Numbers closer to 1 means that those events are more likely. Numbers closer to 0 means that those events are less likely. But we always have to have a number between 0 and 1. And we can express them in a number of different ways. Sometimes we'll use decimals, sometimes fractions, sometimes percents will work well. And we'll work through examples that show each of those. The second rule is a probability of 0 means that the event is impossible. It cannot occur. So for example, the probability that it will rain down donuts tomorrow upon us is 0 unless something really freakish happens. But I'm pretty confident that it's 0. Another way to think of it is, if we roll 1 single die, what's the probability you roll a 7 on that die? Well, there is no 7 on a die, so that has a probability of 0. Conversely, our third rule is a probability of 1 means the event is certainly going to occur. This is going to happen. So for example, the probability that we'll all have a fun time in math class tomorrow, of course, is 1. Okay? So just a couple simple rules. So how do we put it all together to come up with probability? Well, theoretical probability is usually what we're going to compute, and theoretical probability is simply a number which measures the success of an event in a long series of trials. For example, if we were to roll a die over and over and over again, what proportion of the time would it come out as a number 5, or a number 2, or as an even number? We call that theoretical probability. And the way we compute it is with this fraction. We start with the number of favorable outcomes in the numerator, and in the denominator we want the number of total outcomes. So if we can count the number of favorable and the number of total, we can come up with theoretical probability, and this is why writing out the sample space is so important and useful here. So let's take a look at an example here. Let's say we roll a die. What is the probability it shows an even number? Well, let's go through the formula. Theoretical probability is the number of favorable outcomes over the number of possible outcomes, the total outcomes. Think about a die. How many even numbers are there in a die? Well, there's 3 of them, 2, 4, and 6. And how many total outcomes are there when we toss a die? Well, it has 6 sides, so 6 total outcomes. 3 over 6, we can reduce that. We do want to reduce these guys, and 1/2 is a good looking answer here. Okay? Final thing we want to look at is, we looked at dice, we looked at coins, we're also going to look at playing cards. Let's take a minute to think about playing cards. Some facts about playing cards. Playing cards, there's a deck of 52 cards. There's a picture of them in your probability packet. There are 26 red cards and 26 black cards. Each of the cards are broken into what are called suits. They're 4 spades, 4 clubs, 4 hearts, 4 diamonds. And each card has a rank. For example, some are aces, some are tens, some are jacks or queens or kings, and there's 4 of each of them. And the final piece is we're going to use the term face card often in class, and face cards are simply jacks, queens, or kings as one group. And jacks, queens, and kings, there's 4 of each of those, so there are 12 total face cards in the deck of cards. Keep in mind that an ace is not considered a face card. Think about an ace. It doesn't have a picture of someone's face on it, so it's not considered a face card. Okay? So when we deal with probability and we deal with cards, sometimes we'll use this notation. These are the symbols we'll use. Take a look at this. P parentheses ace. That simply means the probability of drawing an ace. It means the probability an ace is drawn from a deck of cards. So you need to be familiar with how to read the symbols here. What is the probability of drawing an ace? Let's go back to our definition here. There are 4 favorable cards here. There are 4 aces in the deck of cards. The number of total cards is 52 cards, so 4 out of 52, which reduces nicely to 1/13. So this video just had some basic ideas. Make sure you have them written all in your notes, and we'll bring these ideas up in class in our next session.